With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
A block of mass m slides down a wedge of mass M as shown. The whole system is at rest. When the height of the block is h above the ground, the wedge surface is smooth and gradually flattens. There is no friction between wedge and ground. If there would have been friction between wedge and the block, which of the following quantities would still remain conserved? So there is no friction here. There is no friction here. But now it says that there is some friction here. Now due to this friction, when this block slides down, what will happen is there will be a tangential component here for the frictional force, and there will be some work done against it, right? And this frictional force will always be tangential to the wedge, to the surface of the wedge along which the block is sliding. But the thing that should be noted is that this frictional force is an internal force for the system. The system being this wedge and this block, so it is an internal force. What that means is that this frictional force will have two components along an x-axis and along y-axis. So along x-axis, the only force that is acting is this frictional force, and that too is internal, and there is no other external force acting along the x-axis, that means along the horizontal. So what that means is that along the horizontal there is no F external. What that means is that along the horizontal the linear momentum will remain conserved. So the first option is linear momentum of the system along horizontal direction is conserved. So yes, that is correct. The second option says that linear momentum of the system along vertical is conserved. Now along the vertical there is one external force that is acting on both the wedge and the block, and that is the force of gravity. And gravity is not a part of the system. So what that means is along the vertical there is some F external. What that means is the linear momentum along the vertical cannot be conserved, which means that linear momentum of the system along vertical direction will not be conserved. So option B is incorrect. Linear momentum of the system along a tangent to the curved surface of the wedge will remain conserved. Now a linear momentum along a tangent will be a combination of linear momentum along the horizontal and along the vertical. Now along the horizontal we have already shown that it is conserved, but along the vertical there is gravity acting. So what that means is that along the vertical it would not be conserved, hence the combination of the two will also not be conserved. So linear momentum of the system along a tangent to the curved surface of the wedge is not conserved. So option C is incorrect. The final option says mechanical energy of the system. Now option D says that the mechanical energy of the system will remain conserved. Now for mechanical energy of a system to remain conserved, the only forces that are acting on it should be conservative forces. But since they have introduced friction in the question now, and friction is a non-conservative force, so friction is non-conservative, therefore there will be some loss of mechanical energy of the system, which means that mechanical energy of the system will no longer remain conserved. So option D is incorrect.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.